Today, we're going to dive into the evolution of a really critical piece of industrial tech, the motor starter. We're going to look at two very different ways of getting absolutely massive electric motors up and running without, blowing up the power grid or the machine itself. So, first, let me ask you a question just to set the stage. We are not talking about your kitchen blender here. I want you to picture a motor for a giant industrial pump or maybe a huge fan in a skyscraper. What do you think actually happens when you just flip the on switch?
Well, what you get is an electrical tidal wave. It's something called inrush current, and it is absolutely immense. I mean, we are talking about a surge that can be up to 600% of the motor's normal, everyday running current. That is just a massive shock to the entire electrical system.
To put that into perspective, think of it like this. It's kind of like flooring the gas pedal in first gear in your car. You get this incredibly violent jolt that puts a ton of stress on everything. The power lines, the motor windings, and all the machinery connected to it, like the gears and drive shafts.
So, for decades, engineers have needed a way to soften that blow. And that brings us to our first solution, a really clever, kind of old-school mechanical trick called the Wye-delta starter.
So, what is it exactly? Well, the Wye-delta starter is a method that basically reduces the stress of that startup. And the key to how it works is that word reconfiguring. It doesn't actually change the power coming from the wall. Instead, it temporarily rewires the motor's internals to make it behave a little gentler. And it does this using a set of heavy-duty switches. They're called contactors. So first, it connects the motor's internal wiring into what's called a Y or a star configuration. This is a much less aggressive way to get things going. Then, after a set amount of time, bam! The switches flip over and they reconfigure the wiring into the more powerful delta shape for normal, full-speed operation. And here's the magic. In that initial Y configuration, the voltage that's actually felt across each of the motor's windings is reduced all the way down to just 57.7% of the full line voltage. This is the soft start that tames that initial electrical tidal wave. But of course, there's always a trade-off, right? You can't get something for nothing. By reducing the voltage that much, you also slash the motor's starting torque, that's its twisting force, down to just 1/3 of what it's normally capable of. Now, for a lot of things, like fans or pumps that don't need a huge shove to get going, this is totally fine.
So this Wye-delta trick, it seems like a perfect, really elegant solution. But there's a flaw. There's a hidden shock in this classic design.
Yep, this purely mechanical trick has a bit of a dark secret, something that happens in the blink of an eye but can have some pretty major consequences for the whole system. And it's called open transition. See, as those contactors are switching from the starting Y configuration over to the running Delta one, for just a split second, the motor is completely disconnected from power. It's literally just spinning on its own, getting no juice at all. So what do you think happens when you suddenly reconnect a spinning motor to full power? Yeah, you get another huge surge. And this transition spike can be so violent that sometimes it's even worse than the initial starting current we were trying to avoid in the first place. It just sends these massive electrical and mechanical shocks ripping through the whole system. Think about it this way. That open transition is basically like shifting a manual car and completely forgetting to use the clutch. You just get this jarring, violent crunch that can damage drive shafts, gears, everything down the line. It's not pretty. This fundamental flaw is really what paved the way for the next step in the evolution. So enter the modern electronic solution, the solid-state soft starter. So instead of these big, clunky mechanical contactors, a soft starter uses solid-state electronics. Think of them like really sophisticated dimmer switches for the motor. It doesn't just jump between two different states. It smoothly and gradually ramps the voltage up from a low starting point all the way to full power. There's no disconnect. There's no violent transition. So if the Wye-delta starter was like that clutchless gear shift, the solid-state starter is like the smooth, seamless, powerful acceleration you feel in a modern electric vehicle. No jolts, no shocks, just pure, controlled power. But fixing that open transition problem is really just the beginning. The shift to solid-state electronics unlocks a whole new level of control and, frankly, intelligence. I mean, the difference is just stark. A Wye-delta starter is kind of a one-trick pony. You get 33% starting torque, and that's it. Take it or leave it. A
A soft starter, on the other hand, is fully adjustable. You can literally dial in the exact starting torque and current your machine needs, everything from a super gentle nudge to a really powerful push. And that right there is the game changer. You're no longer just accepting a brute force reduction in power. You are intelligently controlling the motor, precisely matching its output to the load. And what that means is better performance and a much longer life for all the mechanical parts. And the advantages just keep piling up. These solid-state units are packed with intelligence. They've got built-in motor protection, so they guard against overloads and stalls that could cause really expensive downtime. They offer advanced diagnostics to help you predict failures before they happen. Plus, because they get rid of that mechanical shock, they drastically reduce wear and tear on everything from belts to gearboxes, which means lower maintenance costs and a longer lifespan for the whole system. So when you boil it all down, the evolution is pretty clear, right? We've moved from a fixed brute force mechanical trick to a completely adjustable, intelligent electronic solution. It's really the difference between using a hammer and using a surgical tool. And that kind of leaves us with a final thought. This story of the motor starter is a perfect example of a much broader trend. It makes you wonder, doesn't it? What other brute force technologies that we rely on every single day are just out there, waiting for their own intelligent electronic upgrade?